Okay, friends, welcome back. I think we're ready to start finally. You know, a thought that just occurred to me. Technology is supposed to make your work easier, right? And then look, I spent like 10 minutes clicking different buttons, launching different applications just to get started. I think in the old days, before PowerPoints, you would just come in and start lecturing. It was easy like that, right? Maybe you would do some notes. With I think then they had overhead projectors. You come in and you have your overhead projectors, so you start putting them, right? Then you come in, you have to open your slide deck. Nowadays, you come in, you have to open your slide deck, you have to boot up your computer, you have to check your camera, you have to check your microphone, right? So it looks like there are all those extra steps being added. So hopefully, it improves at least someone's life, right? Maybe those people who cannot join us face to face, I mean, their life, their education is improved. Speaking about that, I found it a bit humorous. Did you see that announcement in Canvas? Like the university said something like, we had many cases of non-MSU students attending lectures. We need to take care of that by requiring login. Did you read that? Maybe it was only for instructors, but there was this like announcement on Canvas page. It basically said something like, we've noticed that many non-MSU students have been attending lectures in Zoom. That has to stop. We'll start requiring MSU authentication. And I was thinking like, why is it such a bad thing? I mean, if somebody outside of MSU attending lectures, like, why does it hurt the university? Maybe it's actually good, right? And people learn something, MSU is spreading its brand to those people who are not MSU students. So I didn't understand like why it's a problem. I mean, unless those people are cursing or showing something bad during those broadcasts, I think that's not a big deal at all. What do you think? Okay.
I think that it is because they use the phrase Zoom bombing, which typically means that a bunch of people will join a class and then start acting absurd.
Okay, maybe that was the case. Somebody bombed Zoom. Well, my problem is not Zoom bombing. My problem is that people are just too quiet on Zoom. They're not making any sound. Just maybe doing something else in sometimes. Well, anyways, I hope your snow week was good. I mean, I hope you enjoyed the snow a little bit, shoveling the snow, driving around town. I have a Honda Civic, and it's not like a good vehicle for snow, but luckily I have new tires. So I was driving around when the main streets were cleared out a little bit, so it wasn't that bad. Although you have to pay attention, of course, because a lot of things can happen when roads are slippery. And now we have spring, right? That's what I find strange about weather here in Western Kentucky. Like the seasons can change like within 48 hours. I remember a couple of years ago, it was like something like 28, 27 degrees. And then in 2 days, it became like close to 70. It was like 68 or something. And it was like in February too. To me, it was like a complete season change in 2 days. Well, anyways, it looks like it's over. I don't think we're going to have snow days or snow weeks anymore. I think we're officially entering the spring season. Friends, today, we will continue and hopefully wrap up our discussion on ERD modeling. We will cover two topics today. We will talk about resolving the so-called non-specific or many-to-many relationship. And then in the second half of the session, we'll talk about data normalization. We'll talk about three normal forms, okay? I usually present those topics as two separate lectures, but I decided to present both of them because I think those topics require you practicing them. When you create your ERD diagram, you need to think about resolving many-to-many relationships. You need to think about normalizing your data model. Hopefully you'll practice all those things on Thursday, because on Thursday we just have a pure lab session. I'll just deliver like a brief lecture lasting 5-10 minutes. And then you will work on your ERD diagrams. Hopefully you will work on resolving many-to-many relationships, normalizing your model, because as I asked you before, I'm hoping that by Thursday, everybody will have a draft of an ERD diagram for assignment 3. It doesn't have to be complete, it doesn't have to be perfect, but let's have a draft so we have something to look at, something to work with when we have our lab session here, okay? And then I would like to give you a couple of announcements. Those are not full announcements. I will repeat those announcements in detail next class. I will discuss them next class in detail. So make sure you don't miss our lecture on Thursday, because I have a series of very important announcements. First thing I would like to mention briefly is that next week will be a different week because we're not going to have any formal lectures. What I would like you to do during next week, I will give you time. I haven't decided yet, to be honest, when to set the deadline, but you need to take exam 1. Okay. So far, the deadline has been set for March 3rd, which is Wednesday, right? Let me think about it. Maybe I'll give you more time. Maybe I'll give you time until Friday. I want to do it in a way where people, I want to set deadlines in a way where people don't put it off until the very end of the week, right? Because there's another thing that you need to do over next week, okay? And that thing is to get started with Microsoft Access. So we're almost done with the theory when it comes to creating databases. Now we need to look at practical functionalities of Microsoft Access, okay? And that's why I'm deliberately kind of taking a pause, because I know that people are at different stages when it comes to understanding databases and Microsoft Access specifically. Maybe there are some people sitting here who took a course devoted to Microsoft Access. And maybe there are people here who have never dealt with any kind of databases before, right? That's why I'm asking people to do it at their own pace. There will be a tutorial. It's a 3-hour tutorial, access tutorial. And I'll update it. I'm not going to use this old tutorial. I'll create another tutorial. I'll post another YouTube tutorial for you, okay? So you need to sit through this tutorial at your own pace, depending on where you stand in relation to Microsoft Access. Hopefully you'll be doing it as the instructor presents all those functionalities of Microsoft Access. You'll be doing the same thing on your own computer, right? So I'll give you some instructions how to get Microsoft Access. It looks like everybody has Microsoft Access. If not, I'll show you how to temporarily get an access to it, okay? Using that virtual desk that MSU has set up for everybody due to COVID, okay? I'll give you another option, but that option sometimes works for me with problems. Like I always have problems downloading things through Microsoft DreamSpark access that MSU has in partnership with Microsoft. Anyways, I'll talk about all those things next class. So make sure you attend the session on Thursday and you pay attention to all those things that we're discussing, okay? But once again, I'd like to say that next week is important. You need to take exam 1. I'm not going to ask you to do it in the lab because of COVID. Usually I require people to come to the lab to take the exam, but because we have some people in Zoom anyway, and because of COVID, I want people get together when we don't really have to, right? So you'll do it at home. Number 2, you'll have to complete Microsoft Access tutorial to make sure you understand basic functionalities of Microsoft Access. Another small announcement that we have an AATP Technology Show and Tell event on Thursday. If you attend technology-related events of AATP, I'm talking about events that are not social, like where you just eat pizza and things like that, you can earn 1% extra credit for this class, right? So I'm offering extra credit for all of my courses because I believe that it's useful for your own professional development to attend events related to information technology, right? So if you attend this event and you submit a proof in the form of a screenshot from Zoom, you'll get 1% extra credit for this class, okay? And again, I'll give you instructions how to submit those proofs on Thursday, okay? So those are my pre-announcements. So let's go to the main agenda for today, which is talking about many-to-many relationships and normalization. So we'll continue our PowerPoint deck found right here. And let me. Hey, friends, if you're joining us in Zoom, I'm assuming you could hear everything that I said, right?
We can.
Yes.
Okay, that would suck
Yes.
if my announcements went without you acknowledging them. Okay, so now you should see my screen. Is this correct? You should see our Canvas page.
Yeah.
Yeah.
Okay, great. So we'll continue with our presentation about ERD modeling or database design. So I'll save my deck right here. By the way, in this presentation, we'll use a couple of extra files. You can open them right now, but I'll give you time later to open those files as well. I'll use this normalization example diagram. It's an XML file that you can open using Draw.io tool, the tool that I showed you last time. So you can open the diagram to see like how we implement those ideas that we discuss in practice. And then you also need to open resolving many-to-many example, this Excel file, but I'll open it with you later on, okay? Okay, sometimes you have a situation, let's say you're developing an ERD diagram, let's say you're working on that ERD diagram for your local library, which is assignment 3. And sometimes you have a situation where you have a many-to-many relationship, okay? Many-to-many relationship means you have many sign. Remember that crowfoot notation that looks like a crow's foot, right? So sometimes you have a situation where you have two crow feet on both sides. That's the so-called many-to-many relationship. Another name for many-to-many relationship is non-specific relationship, okay? So as you can tell from that keyword non-specific, it's not good, right? It's not a good situation. Actually, I don't know for sure why it's called non-specific relationship, so I'm speculating. I guess the relationship is not specific enough so that we can apply that rule about child and parent entities. Remember that rule? So the first part of that rule or approach says that the child entity is on which side?
The many side.
Yeah, it's on the many side. Thank you. So the child entity is on the many side. So once you know where the child entity is, you take primary key from which entity? From the parent entity and insert it into what entity? The child entity, right? That's how you implement a one-to-many relationship. If you have a many-to-many relationship, just like you see right here, the relationship is not specific enough to the point where you don't know like which child is a parent entity, which entity is a parent entity and which entity is a child entity. So the rule does not work here, okay? So that's why it's called non-specific. Last time I showed you at the table level why it doesn't work. Remember I showed you an example why it makes sense at the table level to insert primary key from the parent entity and insert it into the child entity, right? Because if you don't do it that way, then the table of the parent, if you do it the opposite way, you take it from the child entity and insert it into the parent entity, then the table representing that parent entity has to be redesigned each time there's a new child, right? You need to add additional column. So you violate the integrity of the database design each time a new record is added. So it doesn't make sense. It's not a good approach, right? So here we cannot do that. I mean, again, because we have many on both sides, we have a situation where we're going to be adding columns to one of those tables. We'll be violating the design of the database each time a new record has to be added. So it's not the way to go. So what do you do when you have a many-to-many or non-specific relationship? Well, you need to resolve it. Okay, you need to resolve it. And you resolve it by adding the so-called associative entity in between. So you go from here to here. So for example, we have students and majors, or it's called curriculum here. So one student can have one or many majors, one major can have zero many students. It's a many-to-many relationship. We need to resolve it. We resolve it by adding an associative entity in between, okay? Now, this associative entity is a bit artificial. Remember what we said last time that entities represent specific things like objects, concepts, people, geographical locations, right? So not all of those classes are tangible in the sense that some of them are abstract ideas. Like for example, a class, right? Like this class, CIS 307 is an abstract idea. We cannot smell and touch it, right? But it's something that we can give an example of. An associative entity is something that is artificial because it's created for the sole purpose of linking these two entities together. I think in database design, they call associative entities join tables. Join tables are created for the purpose of joining two other tables together, okay? The only real world analogy I can give you, and I don't know whether it will make things even more confusing, but the only real world analogy that comes to my mind is the so-called general ledger in accounting. If you took a course in accounting, you probably know what general ledger is, right? So I think CIS majors are required to take accounting courses. So I guess my question is for you, what is a general ledger in accounting? What about cybersecurity, guys? Do you take accounting? I already forgot. Okay, so did you talk about general ledger? Okay, well, look, it's not a complex thing. A general ledger is like an accounting journal where you record transactions. So whenever something happens, let's say you run a store, I don't know, you buy some inventory, you buy some bread. So you create a record, cash is outgoing, I spent cash, and then bread is incoming. Then somebody came and bought a bottle of milk from your store. So you record milk is out, cash is in, something like that, right? So general ledger is a journal where you record all the transactions, okay? And then from that general ledger, accounting transactions are posted to their corresponding account, let's say cash, accounts receivables, right? But that's the starting point. So the only thing I can say is that an associative entity is like a general ledger. Whenever those two entities come into transaction, whenever they interact with each other, you create an entry there to record that interaction or transaction, okay? So that's the only real world analogy in relation to associative entities that I can think of. One thing that is very important is that an associative entity always has a compound primary key, okay? This compound primary key consists of parts that represent primary keys of the entities it is linking, right? So for example, here, student has student number, student entity has student number as its primary key, and curriculum or major, call it major in those examples, has program of study code as the primary key. So you see, the associative entity called major ID has student number, which is a primary key of that entity, and then program study code, which is a primary key of this entity, as elements of its compound primary key, okay? By the way, you don't have to mark them as foreign keys. At least I haven't seen people doing that because it's kind of clear that those are, this is an associative entity because of the compound primary key. And it's clear that by definition, those primary keys, they come from other entities. So probably that's why you don't need to mark them as foreign keys, okay? So this is an associative entity designed for the sole purpose of joining things together, okay? Now, so now let's look at the visual example, how it looks on a diagram, and then we'll look at the database level, what's happening. And by the way, your associative key can also have attributes that are unique to that associative entity, okay? So let's take a look at how it looks at the diagram level. So let's do this. I'll launch draw.io. That's the tool that I'll use for showing the diagram. And then I'll go back to our Canvas page. And I'll download these two files. I'll download resolving many-to-many example, which is an Excel file. And then I will save that XML diagram from draw.io. This one right here. Okay, let me look at my Excel sheet. I just want to refresh my memory about attributes, what kind of attributes we have there. Okay, while it's loading, I'll open the diagram. Okay, the convention that I'm using here is slightly different. So those are tables. Those are not entities from that entity relations tab. So last time we used these, which represent entities, but that's fine. It doesn't change much for us. Okay, so let's say you have the following situation. You have student entity and you have major entity right here. So I hope you can read it from the screen. Can you read it at the back? Okay. I don't want to make it too big because I will add some additional entities and I want everything to be on the screen. So let's say you have the following situation. We said that last time at Murray State, a student can have 0 majors, which means undeclared, or many majors, which means more than one, right? So this is 0 or many. If we're going this way, we said that a major can be populated by 0 students, which means it's a new major. Nobody has signed up yet for that major, or many students. So it's a many-to-many or non-specific relationship, okay? Why we cannot have this relationship? Well, we cannot implement it at the table level, okay? So for example, let's say, for now, just look at those tables. Let's say we have 2 tables, one for student entity and one for major entity. And some of the attributes are omitted. In other words, we're not using all of the attributes. Then imagine let's say student with ID 1, John, declares, I don't know, CIS as his major. Now, if you're smart, you will say, well, why don't we add a column called major right here, and we'll add 1, which is the primary key for CIS. We'll add 1 to indicate that John is majoring in CIS. Now, sounds like a good solution, but what will happen if John decides to declare computer science as his minor or second major? What are we going to do? Well, it's not a good idea to add a second column, which is called major 2, because it will violate the design of the table. Now, every time a new record is created, we need to redesign the table, right? It's not a good approach. And I hope I'm not going to demonstrate this to you, but you will see that if you do it the opposite way, if you try to insert something here, for example, you add John to CIS, then you add John to CS, it will also require modifying the design of the table. So that's not the way to go, right? So instead, you will create an associative entity called major declaration ID, or sorry, major declaration. Yeah, let's just call it major declaration. That will be the name. Again, why am I selecting this name? I hope that this name reflects like a good name for that transaction that occurs between students and majors. So whenever a student and major come into transaction, that's usually when a student declares his or her major, right? That's the transaction, okay? Outside of those declarations, those two entities, they don't bother each other. So that's why I call it major declaration, because I think that's a good name to represent that transaction, okay? So let's go back to our diagram and we'll see how this thing will be implemented. So first we'll add an associative entity right here. I'll save changes. Yeah, they changed the design of those tables. It's a bit, let me check something. That's the bad thing about using web tools, because they keep changing interface, they keep changing the design and things like that. So let me add this table. They don't even have element for those tables anymore. No, it will make it confusing. Okay, to continue the same kind of look, I'll just add a list. It's called a list, but we'll name it as an entity. So that should be fine, okay? So that will be major declaration. And we'll create a primary key for this major declaration. Let me resize things a little bit. So we'll call it major declaration ID. That will be the primary key for this associative entity. And I told you that the convention that I'm using is that I'm always starting attribute names with the name of the entity itself. Now, this major declaration ID, because it's an associative entity, will have a compound primary key consisting of 2 parts. We'll add student ID, which is a primary key of student entity. And then here, we'll add major name, which is the second part of the primary key of the associative entity, okay? And I said before that sorry. We said before that you see the associative entity can have its own unique attributes as well. So for example, if we need to store in relation to that declaration, we'll store it. For example, let's add quickly major declaration date, and we'll add another one. We'll call it, let's say, student name. I'm making things up on the fly. I'm not sure whether it's a good idea. But we'll add student name as another attribute because we want to keep track of students who declare those majors, okay? So this is our associative entity. Again, let's go back to the table level. This is how it will work. So this is the date variable. And the name is omitted, so we don't have like a big table here. So for example, when John comes to university registrar and declares CIS as his major, we create the following record in that associative entity table. John, who has a student ID of 1, declares CIS, which has an ID of 1, as his major, right? So those two entities came into transaction and we recorded their primary keys. And we also captured the date. That happened in 2015, okay? Then let's say John on the same day, who has student ID 1, declares accounting as his second major. So we create another entry for John. John, student ID 1, declares accounting major ID 4 as his major, okay? So those two entities come into transaction once, we create two times, we create 2 records, okay? Then let's say somebody with the name Lisa, she comes in and she declares computer science as her major. So we create the following entry: 3 representing Lisa, 2 representing computer science, and we put the date or when that transaction occurred, okay? So those are the kind of entries that go into that associative table, associative entity table, okay? Does it make sense so far? Okay, so now you know what kind of table represents this associative entity. So let's go back to our diagram and think about cardinalities between major and major declaration, and also student and major declaration, okay? Okay, going this way. So remember, when we talk about cardinalities, we talk about specific instances, which means specific rows, right? If we take any kind of specific row from major declaration, any kind of entry from that associative entity, so we're going this way, from major declarations to students. If we select any kind of transaction, any kind of row, at the minimum, how many students it will be associated with at the minimum? So one major declaration at the minimum will be associated with how many students at the minimum? And by that, I mean like a record here in the table like that. So if we take any of these entries, we can have thousands of them. What would be the minimum number of students that it is associated with? What would you say? Okay, minimum 1, right? Because every record is for a specific student. What would be the maximum? Well, look, we don't have group declarations, right? Look at the table. Each declaration is for one specific student, right? So this means that one entry here will be associated with exactly one student, right? But if we're going this way from students to major declarations, at the minimum, how many, if you take like any student from that table, at the minimum, how many major declarations will that student be associated with at the minimum?
One.
Well, it depends. At MSU, I think it's 0, right? Because we can have students who are entered in the database in the table as MSU students, but they haven't declared any majors. They're undeclared, right? So it's 0. In other universities, it's 1 indeed. For example, in my former university, everybody got accepted to the university as a specific major, right? So that will be 1. But in our case, it's 0. And what would be the maximum number of major declarations that a student is associated with? Many, right? So we have 0, many, and we have 1 on that side. So we'll find an appropriate cardinality line. So each major declaration is for one specific student. So we put 1. However, a student can declare his or her major 0 many times. Okay. Now, if we're going this way, one major can be declared at the minimum how many times? At the minimum. Any guesses? Well, 0, right? Because let's say it's a new major, nobody has declared it yet, but that major exists. It's offered at the university. And maximum, many, right? So one major can be declared 0, which means nobody has declared it yet, or many times, which means more than one student has signed up. So we have 0 or many. And if we're going this way, one major declaration is at the minimum for how many majors? At the minimum. Okay, that's good. Sometimes people say 0, and to me it looks a bit strange. You're saying like, hello, my name is John. I would like to declare nothing as my major. And you create a record there. He declared nothing as his major. So it doesn't make sense, right? So So minimum, so it's the minimum major declaration is associated with one major. And what's the maximum? One, right? Because each entry for one major, if you want to declare two majors, you create two entries, but one row in this table is always associated with exactly one major. So we need the same line here. Okay. So you see what happened, right? We had a many-to-many relationship, and we resolved that many-to-many relationship by introducing an associative entity and converting it into two one-to-many relationships. Okay. So that's the solution that you need to implement when you have a many-to-many relationship. Resolve it by introducing an associative entity in between. Okay. So hopefully I was able to illustrate to you what this associative entity is at the table level and what it represents. It represents those transactions between the two entities that it's linking. Okay. So now we're done with resolving the non-specific or many-to-many relationship. Now we're not done yet because there is still room for improving that model. And that improvement technique that we'll look at is called normalization, and we'll leave entity discovery for our next class. So we need to improve our data model. We need to make it better. Okay, we need to improve it. We need to make it better. Now, what do we mean by a better or by a good data model? Number one, a good data model is simple. Okay. Have you heard this expression, simplicity is a sign of genius? Have you heard it? Or maybe I'm inventing that proverb myself, but I've heard it somewhere. I agree to this expression 100%. You really need to understand something really well to explain it in a simple fashion, okay? I feel like if you cannot explain it in something in a simple fashion, it means you don't understand it fully yourself, okay? That reminds me of a book of one of my favorite philosophers of science, Imre Lakatos, and he wrote something in his preface. He said that a lot of philosophers, they hide misery of their thought behind complicated, complex sentences and sophisticated vocabulary, right? And in my opinion, Imre Lakatos, he's one of the most profound postmodernist, post-positivist philosophers of science. And if you read his book, his books read like, I don't know, like New York Times. I mean, you can understand what he's talking about, right? And to me, it's a sign of genius. If you can explain very complicated issues in philosophy in a very simple manner, it means you really understand them, right? So it's easy to create complex models. It's hard to create simple models, the ones that are very simple, they don't have any redundancy, okay? By the way, I've noticed there's something cultural. In some cultures, people actually take pride in doing things in the most complicated way possible. To them, it's a sign of some sort of sophistication or intelligence, right? My philosophy, the simpler the better, because sometimes life is just so complex. If you're trying to create a complex solution, it will inevitably break. So a response to complex things is simple solutions, in my opinion, okay? So good data model is simple. A good data model is also non-redundant. Non-redundant means don't store information that you don't really need, okay? Not only you will consume those storage bytes, your database will be unnecessarily large if you store redundant information. Also, those extra attributes or extra entities that you're storing, they will increase complexity of your database. It will make it harder for you to understand, to update, to scale the database. And once your model is simple and redundant, it will be more flexible and adaptable to future needs. I already touched on that point. You can quickly change, modify it, right? Because it's not very complex. It's easy for you to wrap your brain around that model, okay? So this is what we mean by a good data model. Now, how do we improve your data model? Well, the general umbrella term is called data analysis. It's a technique to improve a data model for implementing as a database. So you analyze your data model and you find ways to make it better. Now, the specific approach to making your data better is called normalization, and that's what we're going to talk about next. We're going to talk about normalizing your data model, which is a way of improving your ERD model. Again, I think I already told you that, and it's already written in your assignment 3 description file that your data model that you submit has to be normalized. Okay. If I find violations of normalization, if I find that some of the attributes or entities are not normalized, I will put something like this. 1 NF, or 2 NF, or 3 NF. I'll put it in red ink. So if I put something like this, next to an attribute, it means third normal form is violated. Okay? If I put something like this, it means first normal form is violated. And obviously this means second normal form is violated. So I was saying that I put it on the board that I'll put like abbreviations 1NF, which means first normal form, 2NF, second normal form, and 3NF to indicate that a particular normal form is violated in your ERD diagram, and I'll deduct points because of that. Okay. By the way, there are more than 3 normal forms. There are many of them. I think I remember reading up to 7 normal forms or something like that, right? So those are like very sophisticated, I would say, esoteric nuances of data modeling that we're going to skip. We're just going to concentrate on those 3 basic normal forms that give you the biggest bang for your buck. I mean, they help you improve your model dramatically without getting too much into data analysis and thinking about nuances that are way out there. Okay. By the way, one nuance about normal forms, they're all dependent. There's a hierarchy in the sense that if you're saying that your model is in the third normal form, right? And that's typically the normal, as we said during our business intelligence lecture, that's the normal form at which data is stored in data warehouses. They don't go beyond that. They don't try to make it too complicated, right? So if you're saying that your model is in the third normal form, you're also claiming that it's in the second and first normal form. If you're saying your model is in the second normal form, you're also assuming that it's in the first normal form as well. So now each higher level assumes all previous levels, okay? So that's the nuance of the relationships between normal forms. At least that's what the theory is, okay? So we'll talk about each of those normal forms and we'll see examples on the diagram that I already created, okay? So let's start with the first normal form. I'll read the definition a couple of times. I'll try to explain it using my own words, and then I'll show you how it looks on a diagram, okay? So look, this is what first normal form means. If you're saying that your diagram or your entity is in the first normal form, right? If you're saying that your entity is in the first normal form, it means that you don't have attributes within that entity or series of entities that can possibly have more than one value for a single instance of that entity, okay? Going back to tidy data, this is one of the tidy data principles, right? One variable per column, which means don't try to put more than one value in one column. One of the variables in your assignment 2 that violated that was something related to address. Remember, address was that like long string. And I even wrote to some people that even if you're putting together street address, let's say 240 Story Avenue, technically that's violation of tidy data principle because you're inserting 2 values into one cell, one column, right? One is the house number, the other one is street name. So strictly speaking, those are 2 separate variables, okay? So to rephrase it in a different way, you shouldn't have, in order for you to comply with the first normal form, you shouldn't have attributes, right? Which means columns of a table, right? Which again goes back to the tidy data principle. You shouldn't have attributes that can possibly have more than one value. In other words, you shouldn't have a situation where somebody's trying to insert 2 values into a single cell, okay? Now let's go back to our ERD diagram right here. And by the way, this example is very subtle. I mean, we can argue about it, but I'm just telling you, it's not easy to spot. Do you see in those 3 entities, do you see any attributes that violate first normal form? I see one attribute. Maybe there's more than one, but I see one. And you as a student, you may not know which one it is because you're not dealing with those issues as students, right? But anyways, I'll give you 30 seconds to think about which attribute do you think violates first normal form? Any ideas? Why? So you're saying one student can have 2 names, 2 last names? Well, I think I see what you're saying. You're saying that some people have preferred names and things like that.
No. Like I'm saying, wouldn't that be like the first name and then the last name? Or because those are 2 different.
Well, to me, I don't see a problem here, right? I mean, you cannot have more than one last name, right? We cannot have a situation where, let's say, we enter your information to the table and you have 2 last names. It doesn't make sense, right?
I think what you may be
Uh-huh.
We have student first name and student last name, right?
Okay.
And then we look at major declaration, and at the end of major declaration, we have student name, which is an interpreted variable, right?
Well,
Which
look,
could be
you're talking about something different. I mean, I see that repetition, but look, that's the definition of a first normal form. You take one attribute, anyone, and you see a situation where we will have to enter two values into that column, right? So that's, you're talking about something different. You're talking about the fact that attributes are repeated, right? Which is correct, right? We'll talk about it later, but it's not violation of first normal form. Any ideas? Well, look, maybe there's something I don't understand about your example, but I don't see any problems with first and last name because we don't have a situation when a student has more than one last name. Doesn't make sense, right?
I was talking about the major
Okay.
declaration.
So for example, let's say this is the table we're talking about. So John came, declared CIS as his major, and we added his name, John. So what's the problem here? I mean, I don't see a situation where we have to enter John and let's say Ahmed at the same time. Right? So that's what the first normal form is. Okay, well, thank you for participating in that brainstorming. Good ideas. In my opinion, the attribute that violates first normal form is major college. Because some majors are offered by more than one college. And one of those majors is cybersecurity. Cybersecurity is offered jointly by the College of Engineering and College of Business, right? So if we enter cybersecurity as one of the majors here, right? We'll have a situation where we have to enter College of Business, College of Engineering at the same time. You see? So we have two values for two colleges in the same cell, which is a violation of the first normal form. Okay? So what do? If we have a situation like that, it usually means that this attribute has to be a separate entity. So we delete it from here. And we create a new entity. Sorry, I'll use this one to make it simpler, called college. And here we're going to have college name as the primary key, and then college address, something like that. Now, the problem here is that one college can be associated with, I guess, one or many majors, and one major can be associated with one or many colleges, right? So it's a many-to-many relationship. So we need to resolve it by adding an associative entity in between. So we'll call it so it takes some skill to select it. So we'll call it college major. Again, that's an associative entity. It's like a journal for recording transactions between colleges and majors. It will have a compound primary key, so we'll call it the college major ID. And it will have two parts. The first part will be college name, which is the primary key of the college entity right here. And the second part will be major name, which is the primary key of this major, okay? And then each college major declaration will be at the minimum related to one college and maximum one college, right? But one college can declare a major one or many times, right? And the same thing here for college, each declaration of college major will be for exactly one major, but one major can be declared, let's say, one or many times, because you cannot have like a major without college, right? So that's why I'm saying it's one. Well, maybe you can think more about cardinality later, but that's what comes to my mind right now. So we need something like this. So one college can declare one or many majors, because it's hard for me to imagine a college without any majors. So that's why I'm saying, I'm arguing it's one or many here. And then the same thing goes here. And we'll straighten this out. Okay, so we're done. We eliminated the first normal form violation from our diagram. Okay, so we're done with that first part. So once again, first normal form means you have attributes that can possibly assume more than one value. In that case, it means that it should be a separate entity. That's the solution to that. Okay. Now let's go to the second normal form definition. Now this one may also sound even more esoteric. It's even harder to understand, to imagine what exactly it means. Again, I'll give you like, I'll read the definition. I'll give you my own, my own interpretations of those definitions, and then we'll look at an example. So look, if you're saying your entity, let's see. Okay. So we're talking about second normal form. An entity in the second normal form means it's an entity whose non-primary key attributes are dependent on the full primary key. Okay. So look, there are some important keywords here. Full primary key, because we are saying full primary key, it kind of assumes that we're talking about a compound primary key. So which tells us that this problem may arise in situations where you have a compound primary key. Okay. So that's my interpretation of this definition. If you're saying that your entity is in the second normal form, it means all attributes in that entity that are not a part of the primary key are dependent on the full primary key and not a portion of thereof. Okay. To rephrase it differently, to find a specific value for that attribute, you only need one portion of the primary key and not the full portion. Okay. Now let's go back to our diagram right here, and I'll give you an example of an attribute that depends on the full primary key. And that attribute would be major declaration date. To find out when a particular student declared his or her major, we need to have both student ID and major name. Okay? Maybe it sounds like an artificial, like a silly example, but let's imagine the following situation. Let's say you work at the registrar's office as a database administrator, okay? And you have this table in front of you, okay? And let's change the dates here. I'll just change it to, so you have this table in front of you. I'm interested in the value of this, locating this, the date of when somebody declared his or her major. Let's say I ask you the following question. When did he declare his major? That's literally what I'm asking. When did he declare his major? When did he declare his major? Can you answer that question by looking at the table? So that's literally, I come to your desk and I ask you, when did he declare his major? Can you answer that question? You can answer it? So give me the answer to this question. Why? Why not September 3rd? Look, you're maybe like you're somewhat of a genius. You can give answers to questions that nobody can answer, because I mean we don't know who we're talking about, right? But it's good that you have an answer for a question that cannot be answered, right? So if you're smart, right? If you're smart, you will ask question number one: who are you talking about when you say he, right? Who are you referring to? Because I have many entries in my table, right? So let's say you're asking me, so who are you talking about? And I tell you, I'm talking about John, student ID 1. Can you answer my question now? When did he declare his major? So I'm paraphrasing my question. When did John with student ID 1 declare his major? Can you answer that question? No, why? Yeah, you need a second piece of information, which is which major? Because John, just like any other student, can have multiple entries in the table. So if I ask you, when did John declare CIS as his major? You can answer that question by saying on September 2nd, right? So you see the value of this attribute, which is major declaration date, is dependent on the full primary key. In other words, you need to have both to locate value of the date, right? So this attribute does not violate second normal form. Now going back to our diagram, I would like to give you a hint that there's another attribute here in this entity that violates second normal form. In other words, it's not dependent on the full primary key, but only on portion of thereof. So which attribute is that? I'll give you a hint. I'm talking about major declaration associative entity. So which attribute there violates second normal form? What do you think? Well, I'll give you another hint. Somebody already brought up that problem that you have this issue. So which attribute is that? Student name, right? So this attribute, student name, violates second normal form. Why? Well, because to find out student's name, we don't need to have major name, which is that second portion of the primary key. We only need to have student ID, right? So let's say you're a database administrator working for the registrar. I come to you and ask you, what is his name? Can you tell me what is his name? Can you answer this question? If I ask you, what is that student's name? You cannot answer that question, right? What if I rephrase that question? What is the name of the student with ID 1? Can you answer this question now? You can, right? Because you have the primary key associated with that student, which is student ID. And you can say, when it comes to student ID with 1, we have John with that student ID. So you can answer this question. You don't need to know his major to answer the question. In other words, you don't need the major name, the second portion of the primary key to answer that question, right? So here we have a situation where student name is not dependent on the full primary key, but it's dependent only on a portion of thereof. And that portion is student ID. If that's the case, what's the solution? Well, the solution is that it means that the attribute does not belong here. It belongs to an entity where it depends on the full primary key, which means it belongs to each entity. So we need to delete it from here and put it where? Yeah, here, because here it will depend on the full primary key, which is student ID. So this is an example of a misplaced redundant attribute, right? So second normal form deals with those redundant misplaced attributes, okay? Because look, as a part of your major declaration table, you have student ID. If you want to check the name of that student, you can use this table to check the name. You don't need to record it here, it's redundant, right? Redundant means not necessary, okay? So that's second normal form. Now, the third normal form, I think it's easy to understand. It's very easy to understand. Look, this is what third normal form means. If you're saying your entity is in the third normal form, you don't have non-primary key attributes that are dependent on other non-primary key attributes. To make it very simple, it means that you don't have dependencies among your attributes. And dependencies, they can be of two types. One is mathematical, where one can be calculated from another one, right? So for example, if you have an attribute called revenue and you have an attribute called cost, then you don't, in accordance with the third normal form definition, you don't need to have an attribute called profit because you can always calculate it, right? You calculate profit by subtracting costs from revenues, right? So you don't need to store information about profit, you can calculate it. So that's about minimizing the storage requirement, the complexity of your database, okay? So that's mathematical dependency. An example of a logical dependency would be something like, well, nothing good comes to my mind, but something like, that philosophical example, all bachelors are male by definition, right? Because bachelor is defined as a male who is not married, right? So if you're storing information about bachelors, you don't need to specify their gender because you know that bachelors are also male. You can logically deduct the value of that attribute. If you can logically deduct the value of this attribute, it means you don't need to store this data, this additional data, because it's redundant. You can always do it at the database level. You can write a script that says if bachelor true, then gender male. You don't need to have any data storage requirements here. Okay. Now let's go back to our model. And now look at this diagram, and I see at least two attributes that violate third normal form in terms of mathematical dependency and logical dependency. So which attributes violate third normal form here? Go ahead, please. Okay, student age, and which what is the other attribute that it's related to? Yeah, date of birth. They're related, right? You can calculate student age by subtracting date of birth from today's date, right? In fact, think about it, how silly it is to store somebody's age as an attribute. I mean, what, you're gonna update it every year, you're gonna update your database every year with an updated age, doesn't make sense, right? So you don't need to have student age as long as you have date of birth. That's mathematical dependency, okay? Now, there's also a logical dependency here where we can eliminate some of the attributes. So which attributes do you think participate in a logical relationship here? So major name depends on what, logically speaking? So basically, we're talking about a situation where one attribute can be calculated or deducted from another one. Go ahead, please. Okay, so the value of student academic standing, which means good or bad academic standing, can be deducted from what? From the GPA, right? As students, you know this better. In my former university, I remember the rule of good academic standing was 2.0 GPA. If you drop below 2.0, you're in a bad academic standing, which means that there are certain sanctions applied to you. Like you have something like 1 semester to improve your GPA. You need to see your advisor. You cannot take more than 4 courses, something like that. Do you have similar procedure here? 2.5, something like that, right? But you see what the relationship is. Once you know somebody's GPA, you know whether this person is in a good or bad standing, right? So you don't need that. Okay, so now congratulations, we normalized our model. We went through 3 normal forms and we eliminated attributes and situations that violate first normal form, second normal form, and fourth normal form. This is something you need to do for assignment 3. So once you're done with your ERD model, start thinking about first normal form, second normal form, and third normal form. Once again, first normal form deals with a situation where you have more than one value for a single variable, for a single cell, right? You're trying to insert more than one value into a cell. Second normal form deals with a situation where non-primary key attributes are not dependent on the full primary key, which means they're misplaced. Those attributes need to go where they depend on the full primary key. They're displaced or they're redundant. And third normal form means there are logical or mathematical relationships among attributes that allow you to deduct or calculate one attribute from another one. If an attribute can be calculated, then there's no need to store values of those attributes, right? That's redundant. That makes your database unnecessarily large and complex, okay? Friends, I know that some of the, I don't know, maybe to some of you, those ideas are very simple. Like some people find those ideas to be very complicated. In any case, it's a good exercise for your brain to kind of think about those issues. To be honest with you, I feel like to be a database person, just like to be a statistician or just like to be an accountant, you need to have like a special, I wouldn't call it talent, but special personality trait, right? I remember when I was a graduate student, I took an advanced database design course at the graduate level, and we had very smart people sitting there, including IT professionals, and a lot of them, they could barely pass that course. They really like, it's not that they're not smart, it's just that they don't think the way database developers think about the world. Like their worldview is different, right? So if those ideas seem to be like too esoteric, that's fine, not a big deal. Hopefully next class, we'll practice those ideas. For example, I'll give you a chance. If you would like to discuss with me something, for example, you will say, what do you think about this attribute? Do you think it can be calculated from this attribute? If so, is this a violation of the third normal form? So hopefully we can discuss those ideas. So don't be shy. Next class, I'm hoping everybody will show up. If you're face-to-face student, I'll meet you in the lab. If you're joining us in Zoom, you have to be behind your own computer. But connect to us in Zoom. There will be a short lecture in the beginning, then I'll repeat my announcements once again, and then we'll work on assignment 3. So feel free during the session, don't be shy, to show me a diagram. You can just share your screen with me, or I can come over to you in the lab, and you'll show me like your thinking, your thought process about many-to-many relationships, which was one of the topics they how to resolve them, about normal forms violations. And I'll try to brainstorm with you to help you resolve those situations in your ERD diagram, right? So I guess what I'm trying to say, sorry, this mask is slipping. I keep like jerking my nose. So what I'm trying to say, let's try to put those ideas in practice, and hopefully as we discuss those things, as we work together, they'll become a bit more straightforward. If they're not straightforward already, because maybe you have that mind of a database developer and all those ideas seem to be quite natural to you, okay? So that's the whole point of assignment 3 that we'll continue working next time. Okay, friends, so we are done with our lecture. Now let me take attendance, if you don't mind, before we leave. Clifton,
Here.
Braden, Nathan, Ivante,
Here.
thank you, Aaron, David, Jessica, Hope, Sean,
Here.
Harrison, Tristan, Violet,
Here.
thank you, Mason, Ahmed, not here. Then the Zoom session. Wesley,
Here.
Aaron Haney, not here. Tucker, Tucker, are you there? I think I saw your face. Oh, here you are. I think your mic is off. Janice,
Here.
thank you. Jacob,
Here.
thanks. Caitlin, Caitlin, not here. Jason,
Here.
Brendan,
Here.
Casey.
Here.
All right, thank you very much. I'll see you on Thursday. Please make sure you join us in Zoom because I'll make some important announcements and I will also help you with your assignment 3. So if you don't have any questions or comments, I'll go ahead and disconnect this session. Thank you. All right, bye. See you later.